All right, so then on the back side here, we are looking at this polynomial, and our goal is to graph it as exactly as we can, clearly labeling everything. All right, I am going to, you can use your calculator, okay, so I'm definitely going to put this on in the calculator. And I've typed this in to save some time. I'm going to try Zoom 6 and hope that I see something of interest. Oh my goodness, that is so nice. It does this loopy thing. It goes up and it comes down, so I can see more in the y direction if I really want to. I'm going to go y max of like 60, something like that, and then make that 10. Hopefully I can see it all. Don't really need to do that because what I'm really interested in are these points here. So I'm going to do second in calc and get to 0, option number 2. I'm going to go way out here. I should have maybe made my window a little bit easier to see, but I'm going to go starting on the very, very left. You can see it coming up. And then when this goes negative, I know I'm on the left-hand side. I'm looking at the change. Up now it's positive. That's on the right-hand side. So there's my 0 right there. -6. Okay, so I'm going to 1, 2, 3, 4, 5, -6. It goes through there. Now I'm going to try to find this 0. Same thing. And I get up above it. That's positive. Hit enter, and then I make sure it's negative. I know I've gone below it when it's negative. It's a sign change. And this one is -5. Well, that's nice. -6, -5. It's doing a little bump like that. Let's see if these are, they come in pairs, so I'm not going to waste my time. If one of them does not work, then I know the other one will not be a nice round number. Option 2. So I'm negative. I hit enter. I'm just going to keep going until it becomes positive. There it's positive. And hit enter, and let's see. Okay, that's -3.4. So 1, 2, 3. It's about right there. And I might write that down, -3.44949. And then this is going to go up, and it looks like it's between 1 and 2, 1 and 2, like that. It's going up somewhere like that. I'll figure out later if I want to. All right. It's going down on the right and the left, and that's because of that negative sign there, so that makes sense. Now I'm going to divide those two zeros out that I know, -6 and -5. So -6 is one of my zeros, and I write then -1, -13, -47, -5, and plus 150. I don't need to write the plus there, but I just did. I bring that down. -1, I multiply, I get 6. I add those, I get -7. I multiply those, I get positive 42. Negative times a negative is positive. I add these, I get -5. I multiply those, I get positive 30. I add those, I get 25. 25 times -6 is -150. Add those, and I get 0. I'm so happy. I can just draw a line like this. I love it. And I'm going to use -5. No need to recopy. I just bring that down. -1, multiply, +5. Add those, -2. Multiply those, +10. Add those, +5. Multiply those, -25. I am on a roll. So that is my quadratic. So I know that that's going to go down and be -x² minus 2x plus 5. When is that equal to 0? Question mark. I like getting rid of negatives. It's just a thing I do. -x² plus 2x minus 5 equals 0. When I put this into the quadratic formula, I get -2 plus or minus the square root of 2 squared. That's 4 minus 4 times 1 times -5 all over 2 times a is 2. Well, that's just equal to -2 plus or minus, let's see, that's positive 20. A negative times a negative cancels out 24. The square root of 24, do that off to the side. Radical 24 is 2 and 12 and 2 and 6 and 2 and 3. And I can take out a 2 and a 2 and I'm left with 6. So that's 2 radical 6 all over 2, which equals -1 plus or minus radical 6. Okay? Those are my other zeros. If I put this into the calculator, I'm not even going to waste the time, but if I do, I'm sure I will get that, and I will get that, whatever that would be. So my zeros are -6, -5, -1 plus radical 6, and -1 minus radical 6. Nothing wrong with writing them all out. This intercept right here, oh, I should have seen that. That's obvious. When x is 0, that's 150. I should have known that to make my window bigger. And there we go. All right. Domain and range. The domain is all real numbers, and the range is going to be all numbers less than or equal to 150. So g of x is less than or equal to 150. Okay. And then also it's all real numbers. That's implied. If you forget that, I won't take off points. Okay, we're in the home stretch with this guy, similar to other ones, but we can use our calculator. If I go to y equals and clear that, I've got the other equation typed in here. I just need to turn the equal sign on. And then if I do zoom 6, hopefully that shows something. Oh, that looks promising. At least something's in the window. I'm going to go back and do a little bit of analysis here. I see x's in both places, so I'm going to rewrite that with the x squared factored out. That's x minus 5. Down below, I'm going to see if I can factor this. Let's see, 15 and 2. Yep, I'm going to get x minus 5 and x plus 3. Okay, so x plus 3 and x minus 5. Lo and behold, these guys cancel. That means we're going to have a removable discontinuity. This is basically x squared over x plus 3. All right, that's what g of x is when it's modified. So when is my denominator 0? It's a vertical asymptote at x equals -3. So I go to -3, draw my dotted line. Then my horizontal asymptote, it's bigger on the top, so I realize that this has got no horizontal asymptote. It's going to do some zooming. Clearly, it's showing me exactly what's going on here. When x is 0, I get 0 over 3, so it's going to go through there. And this is where the calculator is really worth that money, because it's going to zoom up like this. It's going to come down here. It's going to be kind of a smooth swoop, and it goes off like that. Well, don't leave it blank. It's doing something over here. Okay, just because you don't see it doesn't mean it's not there. So I'm going to zoom out. I hit zoom, and then the out is option number 3. It doesn't actually zoom out until I hit enter. And there I can start to see it. Okay. This is that heartbeat thing I call, and that is nothing other than the calculator going haywire right around the asymptote. Do you notice how this looks like it's a straight line like this? So I'm going to just go back here and say that down here it's going like that. Okay. Now, if I go back to my zoom 6, it looks like this is going down to 0 there. So I can see that that's the lowest spot. Well, where's the highest spot here? Let's make the window just go a little bit lower than -10. Let's go -20 and change our scale there and just see. Now I can see that part. Okay. This is only the calculator drawing that asymptote. That's not really there. I want to find out for the range, what is that highest point? So I'll do second. Calc maximum is option 4. I'm going to steer it all the way over. It looks like it's going up, but it's going to blip over to the other side. Now it's over here on this part. And there I can see it. I need to be on the left-hand side of my maximum. I'm clearly there now. I'm going to go to the right-hand side of it. Wait till it starts going down. It's going down. Hit it again. And my maximum point, it's thinking, is at -12 when x is -6. So that's from 0 down to -12 is my gap. So that's -12 right there when it goes up and then comes down. All right, and that's at 3, 4, 5, 6. So I'm off a little bit. That's -6. So I guess if I want to be really accurate, I'll draw it like this. That's a good thing to be accurate, okay? So my domain is all real numbers except x cannot be -3. My range is all real numbers such that g of x is always going to be greater than or equal to 0, or g of x is going to be less than or equal to -12. All right? And that is pretty good. If you can do that, you're in good shape. Good luck.